Hello students, today we'll be talking about modified Euler's method. In the Euler's method, there is no scope to improve the value of y. So this improvement can be done using modified Euler's method. Modified Euler's method is also known as predictor corrector method. That is, whatever values we are getting from the Euler's method, that is considered as the predicted value, and now we can correct it using the modified Euler's method. So let us consider the IVP dy by dx is equal to f of xy with the initial conditions y at x naught is equal to y naught. In order to get the approximate value, we find y1, that is the initial approximation, by Euler's method. That is the equation number 1. Now we modify it. That means we are correcting this initial approximation using the modified Euler's method that is given by the equation number 2. When we substitute n is equal to 0, 1, 2 and so on, we are getting the corrected values. So like you can see here, when we put n is equal to 0, we are getting the first approximation of y1, which is denoted by y1 at 1. Then the second approximation of y1 is denoted by y1 at 2 when we substitute n is equal to 1. So we correct the initial approximations until and unless two consecutive values are equal. So we stop at that point, and this procedure is repeated unless the accuracy is achieved. Similarly, we can calculate the y2, y3 using the general formula. And in the predictor corrector method, for each step, the predicted value of yi plus 1 is calculated first using the Euler's method, and then the slopes at the points are calculated and their arithmetic average are added to yi to calculate the corrected value of yi plus 1. So let us consider one question in this. So find the value of y when x is equal to 0.1 and 0.2 given y dash is equal to x square minus y with the initial conditions y at 0 is equal to 1. So here x naught is 0, y naught is 1, f of xy is x square minus y, h is 0.1. So here we have to find out two values, y at 0.1 and y at 0.2. So 0.1 is basically our x1, that is x naught plus h. So we have to calculate y1 here first. Now the initial approximation y1 would be calculated using the normal Euler's method, that is y naught plus h times f of x naught comma y naught, and we are getting it as 0.9. Now I will correct this value, and how we can correct it using the modified Euler's method. The first approximation of y1 would be given by y1 at 1, which is equal to y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 is the initial approximation. So substituting the values, I am getting the corrected value as 0.9055. Now is both these initial and first approximation are equal? No, they are not equal. There is a difference of 0.0055. So this is not the corrected value of y1. So I'll move one step more ahead and I'll calculate the second approximation of y1 sorry. So ये आपको कब तक करना है? तब तक करना है जब तक आपकी दो approximations almost equal ना आ जाए. तो अब हम second approximation find out करेंगे y1 की. I am getting it as 0.905225. Again, you will see that second approximation and first approximation are not equal. So I'll move ahead to the third approximation of y1. So when I calculated that, I am getting 0.90523875. So you will notice one thing, that the second and the third approximation are approximately up to 4 decimal places are equal. So I'll stop here, and the y1, that is the corrected value of y1, or I can say the y at 0.1 is 0.9052. On the similar basis, I can calculate y at 0.2, which is my x2. Now the first initial approximation of y2 is again calculated using the Euler's method, which is y1 plus h times f of x1 comma y1, and this is my predicted value. Now I'll correct this using the modified Euler's method. y2 at 1 is y1 plus h by 2 times f of x1 comma y1 plus f of x2 comma initial approximation of y2. जब इसमें वैल्यूज पुट करी तो मेरा आंसर आ रहा है 0.821656. You will notice again initial and first approximation are not equal. So I'll move ahead to the second approximation of y2. Now again second approximation is not coming out to be equal to the first approximation. So I have to calculate the third approximation of y2. So on the similar basis, थर्ड अप्रोक्सीमेशन जब हमने फाइंड आउट करा तो 4 डेसिमल प्लेसेस पे मेरी वैल्यू आ रही है 0.8214. So as the second and the third approximation are equal, so I'll stop here and that would be my corrected value of y2. So basically Euler's method doesn't give you the improvement, and modified Euler method is a predictor corrector method. In the next lecture, we'll be talking about the another predictor corrector methods. We have Milne's method, we have Adams-Bashwood method that we'll be discussing in the upcoming lectures. So this is the modified Euler's method, and we can practice more questions like this only. Thank you so much.